this video, I will show you how we can implement queues as linked list. Here is link queue. So this is our basically class queuedt, and this is our link queue. That is our main focus in this video. So first of all, you can see that we are creating a new class that is inheriting from our queuedt class, and it is also you can see here we are using linked list structure node type. So let us see what are the private members of this class first. And it says that we have two pointer variables, queue front and queue rear. We do not have here maximum size limit because we are using a linked list. So let us discuss its implementation. First of all, let us see the constructor. This is our default constructor, and it is also parameterless constructors. It simply assigns null pointers to both variables front and rear. And then we have let us see if there are some other constructors. Then we will see the regular operations on the queues. So this is our destructor in which it says write definition on your own. We simply remove all the nodes from the linked list. And then we have equal assignment operator overridden. It is also have to implement by yourself copy constructor. We do not have a parameterized constructor here simply because we do not need any maximum queue size variable. So let us see the remaining functions. First of all is empty queue. If queue front is equal to null pointer, it means we do not have any element to delete. Alright, and if there is full queue function, we are simply returning false because in linked list implementation of queues we do not have any maximum size limit. Then we have initialize queue. In initialize queue, we are simply deleting every node from the queue and setting its rear to null pointer. So we have discussed this logic already in the linked list implementation of the stacks. That it is the same logic of that. Then we have add queue. You know that while we are adding to a queue, only the rear variable is affected. So in this situation, first of all we will create a new node for our new element, and then we will put our new element in the info part of the new node and set its link equal to null pointer. Then we will check that if there is initially queue was empty, then our both variables front and rear will point towards the new node, because after this operation we will have only one element in the queue. Otherwise, if the queue was not empty, then we will set its pointers. And then we have front. It simply returns the element from the front side. It returns from the back side. Then there we have delete queue. In delete queue, basically our front side is affected, and simply we will move the front element to the temp. Then we will move the pointer of front to the next available node. Then we will delete the node, and then we will check if the queue is empty. Then we will set the pointers accordingly. So this is basically our linked list implementation of the queue.